Perfect. Hello, my name is Jesper. I work as a software engineer at TV2 Denmark, which is the largest Danish commercial television broadcaster. And today I'm going to talk a little bit about GraphQL, or basically our use of GraphQL and some of the ways we're using it at TV2 Play. So to begin with, let's have a look at GraphQL. So GraphQL is an abstraction layer that you usually use for APIs. So the way most companies use it is that if you have a set of different services and you want to have like a common schema to cover the different APIs, you can use GraphQL for that. And then based on the schema, GraphQL will make sure that your requests get handled by the correct service. GraphQL is schema-based, as I just mentioned. It's based on JSON, so every request that you make in GraphQL is basically just using POST requests and having a payload that's JSON encrypted or encoded. It supports different ways of handling data, fetching and writing data in general. So the most common ones are queries and mutations. And queries is basically a way of fetching an amount of data that you want based on specific types or fields that you like. And mutations is the write equivalent of that. So read and write, basically. It also is a typed language, which means that it's pretty popular amongst people who use, for instance, TypeScript and React, as it allows you to actually fetch the schema and then having the types that are generated in the schema or that are presented in the schema be generated automatically on your TypeScript, and then having that translated automatically into objects in TypeScript as well. GraphQL is declarative, and that means that you basically get what you want and nothing more and nothing less. So one of the things that makes GraphQL a bit different than traditional REST, for instance, is that traditional REST, you would say, give me user number 1, and then you would basically, or normally you would get like every data on user number 1. While in GraphQL, you pretty much just get what you ask for and not anything else. So you define what fields you would like, and then GraphQL will give you that data. So if we take a look at how that actually looks, hopefully that's visible. So this is like a typical representation of a query. So as you'll notice here that I have I ask for navigation, and inside that there are like different fields that I can ask for. So in this case, I want, for each part of my navigation, I want the title and a path for a specific page, for instance. And then over here, you'll notice that I get the data object back. And then that's the representation of the data that I asked for. And as you will notice, I only get back the fields that I actually requested. If we look at mutations, it's kind of similar to a query, although in this case, you might notice that it looks more like a remote procedure call. So basically, this is the same thing. So I have a mutation where, in this case, I'm trying to represent a progress in, actually this is from TV2 Play as well, where I say this GUID, which is a representation of a program, the user has seen 10 seconds, and total he should be able to see like 600 seconds. So basically, as you'll notice here, this is just it looks like a function call. And that's actually the way you typically would write data using GraphQL or modify data. If we look at the way GraphQL is usually implemented, there are basically two ways of doing it. And one is doing GraphQL server-side or client-side. And as you'll notice here, the nice pink parts is representing the GraphQL implementation. So GraphQL basically consists of a schema and a resolver, or a set of resolvers. And that basically means that inside the schema is the definition for all your fields, your types, and then the resolvers actually handle the way each type or each field is resolved. In this implementation, you'll notice that everything happens inside this app location. So this could happen inside like a web app. It could be inside an iOS app or something like that. And it means that the client has the schema, has the responsibility of the schema and the resolving. It also means that you're able to wrap, if you have like a bunch of REST services and you would like to fetch those, but you want to fetch them with like a relation between different services, you should be able to implement a schema and then the resolvers for resolving the relations between the different services. So that's one way of doing it. The other way is by using a GraphQL gateway. So instead of having it inside the actual app, you could have a gateway service, and the gateway service then has the responsibility of handling the schema and the resolvers. And then in turn, there are like some advantages of doing that, of course, because here, instead of the individual apps having to implement the GraphQL schema and handling the resolvers, we delegate that to a service instead, and then that service will be able to handle all the requests from the different clients, which means that the different clients can have different requirements, they can ask for different fields, and then the gateway will just resolve those independently. All right, so that was a little bit about GraphQL. So let's look at the reason why we switched to using GraphQL over REST. So to begin with, TV2, as I mentioned before, is the largest commercial TV broadcaster, and we have one of the most popular streaming services in Denmark. Unfortunately, you can't read that bottom part, but it says except for Netflix. The streaming market is a pretty interesting thing because in regular TV, we are regulated in a way that we have to say how many people actually view our television broadcasts, but that doesn't go for streaming. So basically streaming, every provider or every streaming provider is allowed to keep it a secret how many users they actually have. We're pretty open about how many subscribers we have, but Netflix are not. So we have no idea how many users they have in Denmark actually. But we have an idea that they're slightly larger than we are. So a few years ago, TV2 Play, actually TV2 Play started back in 2004, and over the years it was based on this pretty large, pretty old PHP monolith. So anyone who has dealt with monoliths or really, really old code base would know that that's not a good idea, especially not if you're trying to scale it to the amount of subscribers that we are. When I started it at TV2 5 years ago, the customer base was around 100,000 paying subscribers, and since then we've grown like to 500,000, above 500,000, and of course that's led to some scalability issues. The old code base wasn't really made for handling the amount of traffic that we get now. Of course, due to the way it was coded like 10 years ago, some of the oldest code, and the developers of course didn't expect us to grow as much. And you usually have a tendency towards saying, it's okay that this doesn't scale, I'll probably have to rewrite it in 5 years anyway. And then 10 years later, someone's nagging you because you made like really terrible code like 10 years ago. So the platform didn't scale, and meanwhile that didn't scale. The demand for availability has just increased. So the Danish population in general has accepted streaming as being a part of their everyday life. And as part of that, you can't really be offline for any larger amount of time in Denmark when it comes to streaming, because people are used to streaming or like regular television broadcasts, And that's just by purely cable, which means that you turn it on, it just works pretty much every time. And the streaming business is kind of different because there's a lot of variables that you don't have in regular broadcasts, which means that everything is transmitted over the internet. Your ISP might be down, your Wi-Fi is shitty Wi-Fi, or you're using a really old Chromecast, which is a terrible device. But in general, people kind of depend on the fact that this just works every time. And that also caused us some issues because every Monday, like last year, every Monday when we had this popular series called Badehotellet, which is, I have no idea what to translate that into. Every Monday we had a new episode of that, and every time that went on, 5 minutes later our platform would be down because everyone went to see the next episode right after it had been sent on TV. And every time we were down, people would go completely apeshit on Facebook, and that happens a lot. Not as much anymore. So that was a major issue for us. And apart from that, the different clients that we have to support has increased over the years. So when I started back in 2014, the landscape was pretty simple. We had web, we had iOS, we had Android. That was basically it. And then we wanted to go on smart TV, we wanted to go on Apple TV, we wanted to go on Android TV. We have even tried going on different consoles. And every time we introduce a new client, that new client has new requirements because the different clients don't represent the content in the same way. Because what makes sense on a mobile phone doesn't make sense on a smart TV, for instance, because the smart TV has a different display, has larger images, it has 4K, stuff like that. So we began seeing differences in clients that allowed us, that required us to rethink the way we talked to our API from the clients. So we looked into a few different ways of doing that. Well, first of all, we started breaking up the PHP monolith into a bunch of different microservices. And then basically 4 years ago, the monolith had been split up into some different parts, different microservices that had their different areas of expertise. And so in the beginning, we actually started by using this pattern. So every client would have to talk to every service. And as you'll notice here, every client would then have to start by talking to our login service, and then it would talk to our client service, which provides it some configuration options. Then it would go to content for metadata on different programs. And then eventually, if you wanted to start playing something like VOD or live content, then you would have to talk to the playback service. So this pattern pretty fast or pretty quickly became an obstacle because every client had to talk to every service, and some of them did it sequentially, which means that they talked to client first, waited for a response, then talked to content 20 times sequentially. And of course that slowed things down a bit. But also one of the things that happened was that every service had to service the different clients in a different manner. So when Smart TV called content, it depended on content actually delivering content in a specific way, while the iOS app would ask for content in a different way or require a different way. So one of the other patterns we looked at was a BFF, or backend for frontend. And backend for frontend is, I believe, originally it was a pattern that was coined by, I believe, SoundCloud, who are still using it. And the difference here is that instead of having every client talk to every service, you have a middle layer for each client type. So you have an API that is specifically for TV, you have an API that's specifically for web, or you have a client that's a service that is specifically for mobile. That of course fixed some of the issues, but still that means that whenever you have to make a new feature, for instance, you would have to implement it in all the different APIs, because whenever a device needed something, a new feature, and the other devices needed it as well, of course you have to implement it everywhere. So eventually we started looking at GraphQL, and GraphQL specifically as an API gateway. So if you remember one of the first slides where I showed that one of the ways of implementing GraphQL is using a gateway service. So instead of having these different other ways of interacting between services and client, we had a look into using GraphQL as a gateway. So every client requests the data that it needs from GraphQL, and then our GraphQL gateway resolves the different calls by calling the services, the dependent services, behind, and then serving up the content as needed for the specific platform. And that's actually the way we ended up implementing it. So if we look at the way our setup is right now, we are using, we've been using Apollo Server 1. That's, if you know anything about GraphQL, that's a pretty old implementation of GraphQL. The current one is Server 2. But we've been running that since 2016. GraphQL as a language has existed, started implementing it at Facebook 2012, and then they released it into the public 2015. And our first service was running at 2016, where we switched iOS to using GraphQL as one of the first clients for some of the calls. Now, recently we got our last platform to using entirely GraphQL for all calls, which is Smart TV. The Smart TV landscape is quite interesting because every provider like LG, Samsung, Philips, they have their own app store, they have their own platform, which means that it's kind of tedious to make an app for all the Smart TV platforms. And it also means that development time is quite long for the different platforms. But most of the other platforms have been using GraphQL for at least a couple of years, and using it for basically everything. There are a few things that we still run outside of GraphQL, which is for now login, for instance. But other than that, most calls are routed through GraphQL. So our gateway, on a regular day, handles 23 million queries, and that usually results in around 6 or 7 calls to downstream services per query. So that would be a total of something like 120 million service calls. And the funny thing is that last year, in November last year, I gave a talk at GraphQL Summit in San Francisco, and I had basically some of the same here, but at that the queries on an average 12 million. So since then, our query amount has just gone up, which is due to, for instance, Smart TV moving to GraphQL. All right. So if we look at some of the things that we've gained from switching from regular REST into using GraphQL. So one of the things we got is we have fewer requests. So as I mentioned before, to begin with, we had all the different clients would have to call all the different services, and some of them would do it sequentially, which usually resulted in sometimes up to 30 different requests to load the front page of Play. And that's down to a few. I'll show some metrics on that in a short while. So fewer requests is one of the things that we really gained from it. And then, instead of doing sequential calls from clients to the different services, we now have the possibility of doing those calls in parallel. The GraphQL standard allows you to supply or require the resolving of multiple queries within one call, which means that you can basically bundle different queries and then just throw them as one post, and then you would get the results back for all queries at once, which is also something that we're making pretty heavy use of. We've gotten much smaller payloads. I have a slide on that also in a short while. In general, there's a lot to be gained from not fetching all the data, but only fetching the data that you actually need. We have a lot of data on different programs. So let's say you want to display the latest episode of TV2 News or the newscast. If you were to get all the actual metadata that we have on that program, that's probably going to be 100K at least. But if you only need a title and a description, that's pretty obvious that that's a stupid idea. So one of the major things that we got from this is much smaller payloads, which in turn gives us a better experience when it comes to mobile phones, for instance, because mobile phones, especially when you're from the rural part of Jutland, as I am originally, where the cellular signals are shitty, you would notice that loading stuff, having something that requires more megabytes of data to be transferred contra actually having something that requires 100K, there's a notable difference in that. It also leads to less amounts of data that's unused. We used to have an issue where we would expose a lot of data and then the clients wouldn't use it at all. And now that we've switched to GraphQL and the clients only ask for the data they actually need, we don't have to expose as many data, of course. So we filter those out before they arrive at the client. It gives us less complexity over the actual data that's exposed because we only expose what's actually or absolutely necessary. And finally, it allows us to easier monitor the data that the clients are requesting, because as all our API calls are routed through the same gateway, we have a way of gathering metrics on each query, which means that for every query that is requested through the gateway, we can basically count up what fields are requested and what objects are requested. And that means that we can keep an eye on the schema, make sure that we're not exposing data that none of the clients are actually using. Or if we're trying to deprecate something in our API, we can make sure that no client is actually still requesting that data. So that's one of the things we make heavily use of as well. So if we look at the actual effect it has had on our iOS, for instance, this is the iOS front page, and previously when we were using the monolith to render the front page of every app, so the way it would work was that at first the app would request navigation content, that means 6 kilobytes of data. Then it would go for structures, and the structures are if you'll see the panels over here, and every panel is what we call a structure. So a structure is basically the scaffolding for a panel. And then for every panel, it would go in and say, okay, so I need the content for this panel, and then I need the content for this panel, and the content for this panel. And for every time we used to do that using the monolith, we would return basically all the metadata on a specific program, even though only the title and subtitle would be required. And that would, in general, require 21 calls. So around 3.2 megabytes of data. That's just text data. That's not even including images. So just for textual data on every program on the front page and every representation on the front page would require around 3.3 megabytes to render the front page. After we switched to using GraphQL, instead of that, we now have iOS requesting navigation, and they do request those in separate calls. For instance, web are a bit better at bundling their calls, but here iOS will request navigation first, which is 533 bytes, and then to fetch all the structures on the front page and all the textual content that is required to display, that's 94 kilobytes. So instead of 3.2 megabytes plus a little extra, that's 94 kilobytes. And then one of the things that we got instead was now that the content is loaded in a different way. The different clients actually load our electronic program guide, which is the small panel that shows what's on TV right now, which comes in at 3.8 kilobyte. So instead of handling data for 3.3 megabytes, we're down to around 98 kilobyte instead, which is quite okay, I guess. Yeah, so that's some of the reasons that we switched to using GraphQL, and some of the things that we have actually gained from doing so. So let's have a look at the way the API actually works. So I'm just gonna switch to something else here. Just gonna go mirroring this. Okay. Let's see if I can scale this up. Is that visible for everyone? Yeah. Okay. Because I can probably switch it into a light mode, I think. If I remember correctly. Yeah. It's probably more. Yeah. Okay. So let's have a look at Play. So this is the front page of Play. And of course I'm using a web browser to browse that. And the implementation of Play on web is done using React. And then we have a server-side rendered version of the front page because some of the panels are the same for all clients. And of course there are no need for the web to call our API every single time. So web is actually one of the best clients that we have in terms of the way they use our API, because they're pretty easy on the API. The other clients, like iOS for instance, they call us every single time. But web has a large amount of caching in front of their calls. So let's have a look at what makes up the front page of Play. So here, you'll notice that there's a navigation here. So if we take a look at our API, this is, I'll just go here. This is the way that a query from web for our navigation would look like. So as you'll notice here, I'm just asking for navigation, and I'm telling the API that I'm Play Web. The reason for that is that we at one point had different navigations for different client types. So iOS would have one set of navigation items and Play Web would have a different, for instance. And then we have versioning for our navigation as well, which means that right now I'm asking for version 2.0. And that's the most recent version of our navigation. So, and then you'll notice here that I should get some nodes back, and then for each node I would like the title of the page, and then in case it has subpages I would like some of those as well, and then for each subpage I would like to have the path and the title as well. So if I trigger that query, you'll notice here that I get an array of nodes back. So the first thing of course is forside, front page, and live TV and explore, udforsk. And then that has some subpages as well, which I'm able to see as well. And all of this is just purely JSON. And that's basically what's required to actually render the front page navigation. Or even when it comes to web, they actually only have things like this. So their query would look like something like that. And that would be basically what they need in order to render the navigation. So that's a pretty simple thing. And if we take a look at the schema over here, And one of the nice things about GraphQL is that the schema is self-documenting. So whenever you have a schema defined, the types that it returns will automatically be generated into a documentation format. So over here, if I'm a new guy and I'm working on a new platform, say for instance right now we're in the process of switching a provider on one of the platforms. So if a new developer comes in and he's like, I have no idea how to talk to this API, he's actually able to browse the types and the queries that is exposed. And this is not done in any manual way at all. This is purely done by the schema configuration, which also means that in terms of me making a navigation query here, I could look up navigation and then I would see, okay, so a navigation query would return a page list. So page list is a concept that we have. Of course, is a list of pages. That makes sense. And then over here, the developer would be able to see, okay, so if I want a navigation, the exclamation mark here means that the attribute or the parameter is required. So here, I would have to specify a platform, which has a type of its own, of course, and then that's basically it. And then I would get a list of pages back, which again is just an array of page objects. And then I would be able to browse into that, see what a page actually represents and what fields are available on a page. As you'll notice here, title and path, as I requested, and subpages and structures. Subpages are, of course, subpages, and structures are the structures I mentioned before. So the documentation for the actual schema is pretty handy, and we've actually seen several occasions where a product owner or a project manager have just been exploring our API because it's pretty easy to get into the habit of actually writing the queries, and it's pretty self-explanatory. So we've had experiences where someone would walk up to us and say, I just explored your API and I was looking into this, and is it okay if I start getting this field as well, because I noticed that it's in the schema, and it's pretty easy to play around with. So that's the navigation part. So let's move into something like a page. So again, the front page has a set of structures here. I'll just refresh just to make sure that it's up to date. And yeah, so the page has some structures, and the structures have some content, of course. And if I look at the query needed for the representation of the front page, in this case, what I'm doing here is I'm saying, okay, please give me the page with the path /. As you noticed before in the navigation, we returned path, and then by having the path, you're able to look up a specific page. And the page then, of course, returns a page object, which in turn have structures, and the different structures have what we call entities. So an entity is just a representation of a singular entity, which in our case could be a movie, an episode, or a series. And then for each of the entities within a structure, I would like to get a GUID, which is an ID representation of the actual entity. And then I would like to get some presentation art. The presentation art is just a thumbnail that we're displaying on the front page. So this should give me all the structures and all the content on the front page. So if I do that, and that's a slightly larger result set, of course, you'll notice here that the structure is the same as before. So I get a page object back, I get structures back, and then the structures is an array of different structures, and then for each structure, I have a set of entities, and I even have here, we actually have a structure that returns no entities. That's because it's a personalized structure. But then for each entity, I can get the presentation art, which means that I can get the image that is needed to represent the program or the movie on the front page. Of course, if I wanted to do something else, I could have things like title, and as you'll notice here, it has we're using a thing called GraphQL Playground, which is a wrapper around GraphQL for just playing around with the schema. And based on the schema definition here, at the point where I am right now, I can see what fields I'm actually able to ask for. So at this point, I'm inside entities, which means that I'm requesting a single entity, and then for that entity, I can say, okay, I would ask for the title, but I would also like the description, but I don't really actually need the GUID. And then, of course, as you'll notice here on the top, just refresh. You'll notice here that it has a title and a subtitle here. And that's, of course, here there's the title, and I didn't ask for the subtitle, but I asked for the description instead. So it's basically up to the client to ask for whatever it wants. All right. So let's see. One more thing. Yeah. When it comes to actually the flexibility of GraphQL, one of the things that we really like around GraphQL or around the way that resolving is handled is that instead of you being bound to saying, okay, I would like the title, then for each field inside your type or inside your result, every field actually potentially can have its own resolver, which means that instead of just asking for title here, title could actually be a function call that accepts parameters. So I could now in this case, title isn't flexible, but title could potentially have attributes or parameters that allows you to define, okay, I want the title, but I just want 20 characters, or I want it uppercased or something like that. And then that is actually possible to do for each single field if you define a resolver for the specific field. So in this case, I really like the movie series called Taken, because that's one of the actual semi-decent movies we have on Play. We don't have a lot of movies. So what I'm doing here is that I'm doing a search query, and I say I'd like to have some movies, and I'd like to query for Taken, of course. And you'll notice here that I get Taken 3, then I get Taken, and then I get Taken 2. So it's sorted in a default way. But I happen to know that when I ask for entities, that's actually also defined in the schema over here. But I know that when I'm getting entities back, an entity array, we made some additional filtering and sorting for that. So here, even though entities is actually just a field inside the schema, the field actually accepts parameters, which allows me to say, okay, I asked for take, and you gave me back the content in some default sorted order, but I would actually like it to be sorted popular or newest or alphabetical. And of course, by adding sort alphabetical to it, it gets sorted in the alphabetical order. And that's basically possible to do inside every field in your entire schema if you want. It's just a matter of writing the resolver for the field. Yes?
How does GraphQL know which field to sort by? Is that part of the resolver, or?
That's part of the resolver. So in this case, we've written a resolver specifically for entity handling. So entities returns an array of the entities you requested, of course, and then we during the actual resolver on entities, we have implemented different sorting algorithms. And you could do that either in the gateway, which we are doing in our case some of the time, or you could pass that down the line to the actual service doing the resolving of the actual content. But it's not a default implementation inside GraphQL. So this is part of the resolving algorithm that is implemented for that specific field.
I assume it's the same with the query, that
Yes.
where you query.
Yeah. And there are, of course, there are some default services that are, there are people doing wrappers around MySQL, for instance, or that allows you to put GraphQL on top of MySQL, and then they, of course, expose some default ways of sorting and handling that you are used to from regular SQL, for instance. But in this case, this is specifically implemented for us. And I can show you some examples on that later on if you want. Okay, let me see. All right. Yeah. All right, I have just one more thing, I think. Just in short thing. So again, coming back to the front page, just to show a quick example. I'm not a quick disclaimer here. I'm not a front-end developer. So my CSS skills are pretty shitty, or poor, at least. This is basically taken straight out of an example that Apollo did a year ago to explain how to interact with GraphQL using React. And I just wanted to show this as an example of how easily you can implement GraphQL queries in a regular React application. So if we go down here, or we could basically start here, the page query that you saw before, this is basically the same one, or it's a representation of that, or a different version of that. So I ask for structures on the front page, I get those back. I ask for title, entities of each structure, and then for every entity, I just want the presentation art, which is the default image for the entity. And then that query is just defined up here. And then down here in my React app, I'm using some default Apollo implementation for actually getting the query tag here. So I'm using something called React Apollo, which is a library that Apollo made. And that allows me to say, okay, I want a query object here, I want a query tag, and inside that, I just want to execute the get structures query, which is defined up here. And then I have some different states that it can return. So it has a loading state, it has an error state, and of course it has a data return state. And then when I get the data back, in case nothing goes wrong, when I get the data back, I just want to render that using the structure that I know that I'm getting back from the GraphQL API. And as you notice here, I just pass through the structures. And then for each structure, I render title. And then for the entities inside the structure, I just loop through those. And I do an image tag. And then, as I noticed, I'm poor at doing front-end development. So of course I don't supply any alt tag here because I don't care about accessibility or anything like that. And I do something else like specifying height in here. Don't do that. But yeah, this is just a quick example to show how easy it actually is to get the result set from a query inside React. All right. I'm just going to go switch back. Okay. So a few things to notice if you want to look into GraphQL other than reading up on the actual spec. So start small. One of the things that we started out by doing was that we basically had a really large schema based on data that we already had or objects that we used to have in our own or old monolith. And that turned out to be a pretty bad idea, because once you have a schema, and especially once you have, if you have different clients that depend on a specific schema, once you have the schema, it's pretty hard to change the schema if clients are already using that. You have to negotiate with the clients every time if you're trying to do something that might be a breaking change. So also build the objects that you know your clients need. In this case, I've seen a lot of cases where GraphQL is being mentioned as an API layer that is made to cater for the clients, and that's actually true. So I think for most cases the client needs are the ones that actually should provide the way you structure the schema, and not the data that you usually expose, because the clients are actually the ones that are going to consume this, and that means that they know exactly what they need, and they should be the ones that are either writing the schema, or they should at least be involved in figuring out how the structure of the schema should be like. One of the things we had some different issues around was caching. So because we added an extra layer in between our services and the clients, caching became pretty important for us, because instead of the clients asking for the same resource all the time, the clients would actually ask for different parts of the resources. So we had to think about the way, instead of having to look at the way clients talk to services, we had to look at the way the gateway resolved the data on downstream services, and we had to change the caching of those because the patterns were quite different from when clients talked directly to services. And then go for speed. One of the things that happens when you implement GraphQL, especially if you're doing it in the gateway pattern, is that the gateway will become pretty chatty, because instead of the clients talking to different services, you will have a client getting a query and then doing multiple queries across different services at once. And if you have a lot of services or a lot of objects in different services that have relations to each other, make sure that you don't have to go to one service, then resolve that, and go to another service and resolve that, and go back to the first service. So intercommunication between services is pretty important, and making sure that your network is up to speed. And that's it. Thank you.